Sweet.
All right, so today we're going to look at Module 1, Part 2. Today's big focus is going to be linear stuff. So systems of equations, systems of inequalities, slope-intercept form. So the first thing is just reminding you of your rate of change, which the rate of change is also known as what? Slope. But remember, it is a rate, okay? So it could be like if it's 3/1, it's increasing 3 feet every minute or something like that. A lot of times they have you interpret. So your slope, this formula will be on the Keystone, so you don't need to memorize it even though you should have it memorized. This one is not on the Keystone, but I think we all know that one at this point, rise over run. Remember, positive slope is going to be going up, negative slope is going down. Make sure you don't mix these two up, which some people have in the past. Mr. Reiner, I was observing his class the other day, he had a good explanation for this. If you're on the treadmill and you're just starting out and the incline is at 0, the treadmill is flat, right? So that's your slope of 0. If you were upping the incline so that it was going this way, which we all know it can't, okay, you would fall off, right? That's why that's an undefined slope. So if that helps you at all, remember which one's which. A lot of times there's a multiple choice question that would be like this. We will say the slope of the line is A, 0, B, undefined, C, 1, D, -1. And you have to pick between those two answers. Okay, so just make sure you know the difference. Slope-intercept form. So interpreting an equation or matching an equation with a word description. So in an experiment, a plant grows 0.05 centimeters per day. The plant had a height of 2 centimeters when the experiment started. Which equation describes the relationship? So take a look over our answer choices. Notice also how they defined the variable. D is the number of days. H is the height in centimeters. Which one would we pick as an equation that matches up with the word description? A, very good. Again, the key thing here is that this is a rate. The 0.05 is a rate per day. Remember, per also usually means multiplication. So that would be this. And our y-intercept was 2. It started at 2, and then it's increasing 0.05 every day. Okay. The next one is interpreting the solution. So this one says, Sylvia studied a new language. The equation describes how many words she knew, which is the variable y, after studying the language for x days. Y equals 5x plus 18. They give us an answer, 6, 48. What does that solution represent? 6 words after 6 days, 6 words after 48 days, 48 words after 6 days, or 48 words after 48 days. So you see how similar they are. Which one is the correct answer? Based on the way they define the variables. Caitlin? C. C. Again, y was the number of words. X was the number of days. So you just have to look back at how they defined the variables and then match up those descriptions with the x and the y. And just make sure you don't mix them up somehow. Okay. Solving systems, we learned 3 different ways. They love systems of equations on Module 1. They love them. You'll see, I would venture to guess, at least 3 questions, if not more. So they may ask you to solve by graphing, substitution, or elimination. If it's a multiple choice question, you could really pick any of the 3 methods and then just select the answer. We also know you could do what if it were a multiple choice question? Cameron? You can plug in all the answers and see which one works, which I know a lot of you did on your final, which is fine. But that can also work on your Keystone. So this one they want us to solve by graphing. So I would graph each line separately. So remember, to graph a line, we're going to start at our y-intercept. Remember, this is on the y-axis. There were a couple people on their midterm. I don't know when it was. Maybe it was a quarterly exam or something. That they started on the x-axis. Make sure for a y-intercept, you're starting on the y-axis at 1. Then you're going to use your slope, rise over run. So this will go up 1 and over 2. Up 1 and over 2, up 1 and over 2, and then obviously connect those with a line. Start the next line at the y-intercept of +8. Now what do I do when the slope isn't a fraction? It's -3. How would I use rise over run? Hear it? Good. Put it over a 1, and then this would show that I'm going down 3. You are still going to the right 1. You do not go backwards. That would be if it were a -1, and if that occurred, then this would actually be a +3 slope. Okay, so if it's a negative line, make sure you're still going to the right. Continue that down 3 and over 1, and you can see that's where they intersect. So you could stop at that point. So the solution is, again, where these two lines cross, right here. And we write it as an ordered pair, which would be 2, 2. Okay, the next one is solving by substitution. So substitution is when you would actually solve an equation for a single variable, which this one's already solved for y. So since y equals this expression, you can take this expression and plug it in for y in the second equation. Okay, so we substitute in this whole thing for y. I get -4x plus 8 equals x plus 7. And we solve for x. So add 4x to both sides. Okay, make sure you don't rush it mentally and think that x is 3, because you should be subtracting 7 from both sides instead of adding it. Okay, also divide both sides by 5. Make sure you don't think the answer is 5, because I'm sure if this were multiple choice, one of the answer choices would have 5, but it's really 1/5. Or 0.2 if you prefer, as your x coordinate. To get your y value, we plug it back into one of the two equations. I'm going to choose equation 2 because 7 plus 0.2 is 7.2. That's easy to do mentally. And then we would write these as an ordered pair. So it would be 0.2, 7.2. Make sure you always have it in the order x, y. Sometimes that on the multiple choice we'll switch those up, try and trick you. All right, the last type is elimination, which if I were to venture which type of solving you'll see the most, it's elimination. Okay, they give you a lot of equations, and a lot of the word problems that you do, the equation will be in standard form, therefore elimination is the easiest. Who remembers how we solve by elimination? What do we do? We're eliminating one of the variables. Eric?
Multiply one of the equations to make what on the actual y solve.
Perfect. You're going to get the coefficients to match. To do that, you're multiplying one or both of the equations by a number to get them to match. Okay, so for instance, for this one, I would probably multiply this one by 2 so that it matches. Now, when you do that, make sure you're multiplying all three terms by 2. So we'll get 6x minus 2y equals 10. Biggest mistake is forgetting to distribute that all the way over. Equation 1 stays exactly as is. And then you're going to either add or subtract the equations. And exactly what Garrett said, we want to eliminate the y variable. So we want this to become 0y. So I will add them because 2 plus a -2 would be 0. And I had a little saying also, different signs add, same signs subtract, if anyone remembers that. But if you do get them to be different signs, you'll always be adding, which is the easier method. So we add down 2x plus 6x is 8x. 2 plus -2 is 0, so I won't write anything. And then 6 plus 10 is 16. Divide both sides by 8, and we get x is 2. Take that number and plug it back in for one of the equations for x, since that's an x value. Multiply to get 4. Subtract 4. And divide to get y is 1. Take your two answers and write them as an ordered pair, 2, 1. Okay, equation 2, or I should say system of equations 2. Which equation do you think I should manipulate to get the coefficients to match? The first one or the second one? Cameron? The first one, what do you want to multiply by? 4. You also could multiply by a -4, and if you do that, you'll get different signs, which then you'll add them instead of subtracting, but it's up to you. So doing this one, I will get 4x plus 16y equals 28. The bottom one stays the same, 4x minus 3y equals 9. And then I put my big addition or subtraction bar. Would I be adding or subtracting these equations to get the x to become 0? What do you think? 4 plus 4 or 4 minus 4? Minus. Okay, again, same sign since they're both positive 4s, that's why it's the same sign as subtract. So 4 minus 4 is 0. Now be careful. 16 minus a -3. Minus a negative becomes a positive. So this would really be 16 plus 3, which is 19y. And then 28 minus 9 is 19. Divide and we get y is 1. Take that y value and plug it back in. And just for time's sake, I'll tell you what we get. We will get x is 3. So our solution would be 3,1. Okay. Again, if multiple choice, you could take all of your answers and plug them in and figure out which one works. Okay, the next set of objectives are all inequalities. So just kind of skipping 2 slides ahead, I gave some keywords for what the inequalities stand for. I think most of them are common sense, except for the ones that students mix up a lot. So a lot of people think at least is less than or equal to, just because of the least, less kind of plain words. Remember, at least means you really want more than that. That's the very minimum you want. Okay, so that's greater than or equal to. And the other one I feel like some students get confused with is at most. So that's at the very most, you really want less than or equal to. Okay. All right, so this one, going back my one question. We are asked to write a linear inequality to describe the situation. Suppose you intend to spend no more than $60 on books. So no more than would be less than or equal to. Hardback books cost $12 and paperback books cost $5. How many books of each type can you buy? So you'd want to define variables. Let's let x equal the number of hardback books. And let's let y equal the number of paperbacks, which normally we'd write that out, but for time's sake, we'll kind of shortcut it. So who thinks they could write a linear inequality? So just one, not a system. Just a single linear inequality to describe the situation. Carson? Very good. Okay. Now, they ask us to graph this. You have 2 options. You could get it in slope-intercept form, so subtract 12x and divide everything by 5. But remember, when it's in standard form, you can use the intercepts to graph a little bit faster, okay? Especially because sometimes you count by different things on the x and the y axis. So you'll plug in 0 for x and 0 for y, 2 separate times, obviously, and solve for the other variables. So if I plug in 0 for x, I'm left with 5y is less than or equal to 60. Divide by 5, I get y is less than or equal to 12. So my intercept would be 0, 12. When I plug 0 in for y, I'll get 12x is less than or equal to 60. So x is less than or equal to 5. So my x-axis, I need to get to 5. So 1, 2, 3, 4, 5. Put a point. On the y-axis, I need to get to 12. So I would count by 2's. And I will put a closed circle. Now remember, when you graph an inequality, you could use a solid or a dashed line. Since this one has an equal bar, I will use a solid line. And then I will shade appropriately. It was a less than or equal to. So I would shade underneath the line. And then asks you to write two possible solutions. That's anything in the shaded region. So for example, 1, 2, and 1, 4. But there's lots of possible answers for that. The other types of inequalities you might see are compound inequalities. I'm not going to do both of these since we are a little short on time. But you'll see your ands. Also, you could see the ors. I didn't put any on there because ors kind of just solve two separate in graph. So I'm going to do example B because that's the more difficult one. Okay. So when you solve a compound inequality, you literally solve it just like an equation, but you're doing it inverse operations on all three parts. So this one's kind of out of order. So the 5 is really a positive 5. So I'm going to do the inverse, which is to subtract 5 from all three parts. So we'll have negative 10 is less than, negative 2x is less than 8. Then I would need to divide all of the parts by negative 2. What happens when I divide by a negative number? Garrett? Good. You have to flip your inequality. Okay, and you actually have to flip both of them. So this would become positive 5 is greater than x is greater than negative 4. And then at the end of the problem, if your answer is not in order from least to greatest, see how the biggest number comes first and the smallest number comes at the end? You do have to rewrite this so that it's in standard form, which would be negative 4 is less than x is less than 5. So you basically just flip the whole thing, numbers and answers. And then to graph this, we would do our open circles on each of our critical points, and we would be shading all the values in between those. Okay, we also have absolute value equations and inequalities. So we just went over these when we were reviewing for the final also. I think some of you may remember. But I put the steps on here also to remind you. We can solve these by isolating the absolute value. So that's the most important first part. You have to get this by itself. Okay, and then you can set up your two equations, one positive and one negative. So in this case, I would undo subtraction with addition. So I'll get 15. Then I would need to undo multiplication with division. So I'll get the absolute value of 4w minus 1 equals 5. Only at that point can you set up your two equations. So we'll have 4w minus 1 equals positive 5. 4w minus 1 equals negative 5. They really like absolute value equations and inequalities on the Keystone also. So this is something you're not super familiar with doing. You might want to go back and look over it again or do some more practice problems. This was in section 1.5 in your notes in case you want to go back and redo problems. And you solve each one separately. So adding 1 and dividing by 4, 6/4 is 3/2, which is 1.5. And adding 1, we'll get negative 4 divided by 4, negative 1. Two answers. Now the inequalities, you're going to do the same exact thing, but instead of setting up two equations, you're going to set up two inequalities. And we won't go through all of these, but just remember the little play on words. What type of inequality would I do for this one? An and or an or for letter A? Garrett? The or. Remember the play on words is this is a great or compound inequality. I'll set it up, but then we won't solve them, okay? So 3x plus 6 is greater than or equal to 12, or 3x plus 6 is less than or equal to negative 12. And then you would just solve each of these separately. Now for part B, your steps from the equations are still the same. You have to isolate this before you set up your compound inequality. So you would need to add 9 to both sides, which will get me 24. Then I would need to divide by 3 on both sides to get 2x plus 6 is less than 8. Then we can do our compounds. This is a less than okay? Which usually when I do the and, I don't set up two separate, I do that string of inequalities. So I would have positive and negative 8, so negative 8 and positive 8 would be my two end points. And then the 2x plus 6 goes in the middle. And then these would be both less than symbols, so that it's already in a compound inequality format. And then you would just solve from here. So subtracting 6 on all of our parts. And dividing by 2. We'll get negative 7 is less than x is less than 1. So the answers are always going to be written with that if it's an and anyways. Now if you prefer, you could do what we did on this one. You just have the word and then at the end you'd have to put them together, the two answers. Alright. Last set of examples are systems of inequalities, so that's just graphing a line, shading it, graphing another line, shading it, looking for where they overlap. So let's go ahead and just do one of these questions. Let's do this one, actually, 'cause it's the harder one. So for this one, we would start at positive, for the first one, start at positive 2 on my y-axis, count up 3 and over 1, up 3 and over 1. Would I use a solid or a dashed line? Dash. I'll use my line tool here. Cheat a little bit. And then for this one, we would be shading greater than is above. So we should be shading lightly above that line. Now, before I graph the second one, I probably want to solve this one for y. Okay, I get it in the slope-intercept form. So to start out, I would add 2x to both sides. So I have negative y is less than or equal to 2x plus 4. Then I would have to divide by a negative 1 everywhere, which again, whenever you divide by that negative, you have to flip your sign. So this becomes y is greater than or equal to negative 2x minus 4. So I'll start at negative 4, and I'll count down 2, over 1, down 2, and over 1. This one will get a solid line. And this one now, since we changed the sign, we would shade above the line. So the solution set is just where they overlap, which is right here. And on the Keystone, I think that they may just have that part shaded. I don't know that they do the other two parts, because that's really not part of the solution. Okay, I'm going to do the next problem on the video, but I'm not going to do it in class since we only have 3 minutes left. Your homework for tonight is to finish that packet. So you're doing numbers 15 to 30 and 33 to 37. So I'm going to go ahead and finish the last example that we had. This one says a group of friends will buy at most 8 snacks. So at most would be less than or equal to at the movie theater, and also spend no more than $42. No more than is also less than or equal to. They pay $6 for each box of candy and $3 for each bag of popcorn. Write a system of inequalities, so that means 2 or more, to model this scenario. They also define the variables. X is boxes of candy, Y is the number of bags of popcorn. So remember, money is going to go in an inequality with money. So we should have $6 for each box of candy would be 6x plus 3y. So that's money, money. We're going to use the money, $42, for this inequality. Okay, now the other one, there's no information really about snacks. But remember, X stands for the number of candy snacks we buy. Y stands for the number of popcorn snacks we buy, together that has to be at most 8. So that should be just plain old x plus y is less than or equal to 8. Okay. Then we're going to graph these. So to graph these, remember the easiest way is to use your intercepts. So if I plug in 0 for x and 0 for y, I would get y is less than or equal to 8 and x is less than or equal to 8. So for this one, I would put a closed circle on 8 and 8. I would put a solid segment, actually, between those 2 points. And then for my shading purposes, I am looking for less than or equal to, so that would be underneath my curve. Okay, now for the other one, I would do the same thing, plugging in my intercepts. So I'll do my x is 0 and my y is 0. So when I plug in 0 for x, I'll get 3y is less than or equal to 42. And that'll get me y is less than or equal to 14. When I plug in 0 for y, I'll get 6x is less than or equal to 42. Dividing by 6, x is less than or equal to 7. So on the x-axis, I'd put a dot at 7. The y-axis, I would put a dot at 14. Again, they have an equal bar, so I am going to connect those with a solid line. And I'm also shading underneath this curve. Okay. So my final answer is where these pink and blue shaded regions overlap, which occurs here. So this is the solution set of all the combinations in between. Now remember, when you're answering part B, it asks you to identify any possible combinations. You're not going to pick decimals or fractions because you cannot purchase half a bag of popcorn or half a box of candy. So we would pick whole numbers for that. So for example, 2, 4, or 4, 2 would also work. But there are also obviously lots of combinations like 1, 2, 1, 1, 1, 3, 1, 4, 1, 5, 6. You could even pick something on the solid line because it's not dashed. And that's how we would solve a word problem involving systems of inequalities.